Hi friends, see in electrostatics we have completed up to 4 parts. Now we are left over with last part of electrostatics, okay, part 5. See, last part of electrostatics is left over. Let us complete with a small one left over, electrostatics, okay. So in last part we are left over with, already I told you in up to 4 Wheatstone bridge problems by using potential method, easy method, potential method. In the same fashion, if you go for infinity series, ladder problems, that is ladder problems, which is also called as infinity series. And if you want the infinity series, for example, if you are given like this, for example, say, okay, one capacitor like this, another one, okay, another one like this, continuously, okay. So E-type problems, how to solve such type of, because these are coming regularly in the examination nowadays. I will give general form, okay, how to solve general form. If any values are there, you can continue with that one. See, this is continuing up to infinity. You can see in such cases sometimes they may give different values or sometimes they may give same values. Here what I am doing is I am taking same value C, 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 C. So this is going up to infinity. Let this be A and B. Now the question is, what is the effective value between A and B? Between A and B, what is the effective capacitance? What is the effective capacitance? So in such cases, what you have to use small logic. So suppose if I have started solving from infinity, see infinity lonchi 2, 3 ఎన్ని మైనస్ చేసినా ఇన్ఫినిటీలో వాల్యూ తగ్గదు. There is no difference if you minus some boxes from infinity. So what I will do, I think that I have solved some boxes and suppose up to here I have come. Up to here I have come, for example, assume like that. So up to here, so many infinity boxes are there. Up to here, let the value be Cx, effective value. Okay? So infinity boxes are there, I have solved there. Up to here, let the value be Cx. Now these Cx and this C, both are parallel. What is the effective one for parallel? C plus Cx for parallel. I told you in resistances, current and resistance and capacitance, there is reverse process. Series parallel, parallel series formula. So here parallel means formula is C plus Ch. Again if you see with this one it is series. So with series means what happens? C plus Cx into C by C plus Cx plus C. R1 R2 by R1 plus R, లేదా C1 C2 by. Up to here if you solve it, ఇక్కడ వరకు value ఏమని చెప్పండి Cx. And this in series. Okay? Up to here. Suppose if you solve up to here, just now, see Cx value ikkada. Cx అయినప్పుడు ఈ value ఎంత అయింది? What is the value here? Cx are parallel. So C plus Cx. Again this one with series. So Cx into C by Cx plus C. And again what happens with this one? It is again parallel. Okay? Again with parallel means again what? Plus C. And this is equal to again what? Your x, Cx value. This is the process you have to adopt in solving infinity problems. You think that you have solved the problems from infinity and you came up to here. Let this value be Cx. The Cx and C parallel. So C plus C, the effective value. And with this again series. C plus x in this thing. Again with this one parallel. And this is equal to Cx value. Now let us solve this equation. We'll see what happens. C into C. C square plus C Cx by, here how much you got? 2C, okay? 2C plus Cx plus C is equal to Cx. If you take LCM and solve this one, how much you will get? Take LCM, C square plus CCx plus 2c square plus ccx, okay, by this thing again multiply this. So I'll take it here directly, 2ccx plus cx square, okay, taking LCM, one time c square plus ccx, okay, plus 2c square plus ccx is equal to this one, multiplication again this one. So when you do this like this, student, common terms are there, 2ccx, okay, let us see one, c square, 2c square. So first ccx, 2ccx plus 3c square, c square plus 2c square is equal to 2ccx plus cx square. See whether it is right or wrong. Ikkada ccx, 3c square, 2ccx, cx. See, I have done here wrong. Let us take up once again from back. C into c square plus ccx by, see here what I have done, a value, I thought that this one is cx value. Cx and c, again they are parallel. So c plus cx, again it is with this one series. Okay, so c plus cx into c by c plus cx plus c, again with this one parallel plus c, LCM, okay, so 2c plus cx, yes, let me check once here, once again I am checking, some value I think I got wrong, let me check once again. See here LCM ante indi ikkada, 2c plus cx, one time c square plus cx plus one time, okay, 1 plus 1 into this thing, c into 2c plus cx is equal to cx. Let me check. So now I got some value. Let me see the value. What is the value? See, even though it is a big process, you have to solve it because general process I am telling you. So here c square plus ccx plus 2c square plus ccx, this is equal to 2ccx plus cx square. Same value you are getting again. Okay, cx, how much? 2cx, and here 2cx cancel. Take all the terms to the other side. Okay, cx square, c square plus 2c square, 3c square you are getting. Okay, so here I think you are getting some different value here. C square, 3c square, or at this scale the minus 3c square is equal to 0 you are getting. Okay, we will do one thing. If that is the case, we will do one thing, we will change the problem. Okay, because generally what I am trying to tell you is, for general problem if you solve, what you will get. Okay, so for example I will do one thing. It is better I will give some values. Then we will try it. Okay, I will give some values for you. For example, take here value as 2 1 2 1 2 1 2 1 continues. 2 1 2 1 is repeating. Here middle all 1. You can take some value microcoulombs. Identity capacity microfarads or millifarads, something. Microfarads or millifarads, something you can take because it is a capacitance kada, microfarad. See, please see this one before problem, just roughly I have taken. because it is coming little difficulty. So I am giving some values and now let us try the problem. Into the 1 microcoulomb, 2 1, 2 1 is repeating. Same principle I will apply again. Let this value be some x. I have solved from infinity, let this value be x. Now this x and 1. Now this x and 1 are in parallel. So what is the value? 1 plus x. And with this one it is again series. So 1 plus x into 2 by 1 plus x plus 2. 1 plus x plus 2. And again with this one it is parallel plus 1 and this will be equal to x. Please check it. This will be equal to x. Oksa chuskondi. I have solved from infinity. I have given some values. Repeating 2 1 2 1 is repeating. So all the boxes I have solved and I came up to here. Let this value be x. Okay. Infinity launch రెండు కాదు కదా 3 బాక్సులు ఎన్ని బాక్సులు మైనస్ చేసినా వాల్యూ తగ్గదు. So that is in that fashion I am taking. So what happens finally? 1 and x are parallel. So 1 and 1 plus x effective. Again series into 2 by 1 plus x plus 2. Again parallel plus 1. ఇది ట్రై చేద్దాం, సాల్వ్ చేద్దాం. We'll see what happens with the value. So ఎంత అవుతుంది ఇది? 2 plus 2x by 3 plus x plus 1 is equal to x. Clear? Now let us try to solve this one. LCM 3 plus x 2 plus 2x plus 3 plus x is equal to x. See, even though it is a laborious, you have to solve it please. 2 plus 2x plus 3 plus x by 3 plus x is equal to x. Now let us see what is happening here. ఎంత వచ్చింది వాల్యూ ఇక్కడ పైన? 2 plus 3 5, 2x plus x 3x, and this one how much? Same thing you are getting again. Same value you are getting. 1 plus x into 2 by 1 plus x plus 2 plus 1 is equal to x. వాల్యూస్ అన్న మార్చామా చూడండి ఒకసారి. Here the values are given as 1. Okay. 2 into x by 2 plus x. Let me check up. 2 into x by 2 plus x. 2 into x by 2 plus x. Okay. We'll do one thing. I think this problem is going in a different fashion. The solution is going in a different method. Let us try one more. Okay. 2 into x by 2 plus x plus 1 is equal to x. 2 into x plus 2 plus x is equal to 2x plus x square. Okay. 3x plus 2 is equal to 2x plus x square, or this side x square minus x minus 2 is equal to 0. So this is the final equation I got. Okay. x square minus x. అంటే ఇక్కడ జరిగిన విషయం ఏంటంటే this block not up to here, you have to take up to here. Up to here you have to take value. So this value is taken as x. Then this x and this 2 what happens? Series. So 2 into x by 2 plus x. Again this one parallel plus 1 is equal to x. If you go like that you will solve, not up to here please. Okay. So sorry for that one, please copy again. So finally got it as a quadratic equation. So what are the roots for this quadratic equation? Minus b plus or minus root over b square minus 4ac by 2a. So there is a solution for this one. You have. So minus b. So So what is this is in the form of what? Ax square plus bx. Ax square plus bx plus c is equal to 0. What is a value? 1. What is b? Minus 1. C minus 2. So minus b and ఎంత అవుతుంది? minus b. Minus 1 plus minus root over b square minus 4a c by 2a, 2 into 1. Now if you solve that one, finally we got the solution. Okay. If you solve it, or you will get it as minus 1 plus minus root over minus b kada, minus of minus plus, plus on root over b square minus into minus plus 4 to the 8 by 2. So square root of 9 is 3, therefore 1 plus minus 8 plus 1, square root of 9 kada, 3 by 2. So one value ఎంత అవుతుంది? First value 1 plus 3 by 2, that is 4 by 2. 1 is 2. Another is 1 minus 3 by 2, that is minus 2. 1 minus 3, minus 2 by 2, ఎంత అవుతుంది? Minus 1. So minus 1 you cannot take the value. So what is the value? 2. So what is the effective value of this entire infinity series? C effective is equal to 2 microfarads. ఇదండి పరిస్థితి. See, it has taken so much of time this problem. So ఈ ప్రాబ్లం మనకి చాలా జాగ్రత్తగా సాల్వ్ చేస్తే కానీ మనకు రాదు. You have tried 2 to 3 times I think. Okay. So this is the how you have to solve it, and that is the final answer. So infinity problems you have to solve in such a way. Otherwise you won't get the correct solution, because you will be getting in a quadratic form, and from that you have to calculate the value. Now let us go to the next version. Next version ఒక్కోసారి ఎగ్జామినేషన్లో మీకు ఏం చేస్తారంటే ఈ టైప్లో ఇవ్వచ్చు. For example, these are cube. Okay. For example, different cubes I am drawing for you. You have to remember the values in the examination. They may be asking in NEET and MSET. Okay. Different cubes I am drawing. We'll try to solve. Derivation I am not doing, directly I will give the. So here cubes are there, 3 different cubes. And here, first one is effective value between these two, A and B. Effective value between those two. Okay, you can call this one as body diagonal. You can call this one as body diagonal, and all are having equal values, please. All are having equal values. Equal values. Capacitance. Okay. Same value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 వస్తాయి మొత్తం చూసుకోండి. ఓకేనా? ఇక one more here, 12. So if such cases it is given like this, if they are asking in the examination to find the effective value, capacitance, అన్ని ఈక్వల్ వాల్యూస్ ఇస్తారండి మీకు. you will be giving equal values. So this is equal value, C, capacitance value, equal values. Okay, all are equal. In such cases, how to solve? If they are asking in different fashion, that is body diagonal, face diagonal, side diagonal, etc., etc. Okay. Now this is body diagonal. If in this case, if you ask what is the effective value between A and B, you can get an easy method is there. The value goes like this: 12 by 10C. Effective value is 12 by 10C. So the effective value between A and B for body diagonal is such a cube. Okay? If all the values are same, then the value is 12 by 10C. Now second case, if you ask you side one, okay? This is side. A and B. Okay? Between these two sides, A and B. What is the effective value if you ask? This value goes like this. C, effective capacitance, is equal to 12 by 7C. Where C is the value, original value given. 12 by 7 is a 5. Because to remember in a better manner, I am making all 12 values. Because here you can, if you divide 2 6s are 2 5s are 6 by 5c అవుతుంది. కానీ మెమరీలో ఉంచుకోవడం కోసం just I am multiplying with some figure and making all the values as 12. So this is called a side. Now another one is their last one. That is also you may ask in the examination. What is the effective value between that side and this side? Okay, and this value goes as 12 by 9c. 12 by 9c. Okay, clear? So this is called as face diagonal. This is face diagonal. So in the examination, what is the effective value between face diagonal means 12 by 9c, body diagonal 12 by 10c, this side and this side, and side diagonal 12 by 7c. Second one is side diagonal. And side diagonal. Please try to remember these values. In the examination, if they ask body diagonal value, effective value, if all the values are same, 12 by 10c, side diagonal 12 by 7c, and face diagonal 12 by 9c, please. Copy it? Right. Now let us go to the dielectric medium, next one. Let us go to the next one, dielectric medium. Okay? Right. So, what is a dielectric material generally? See, dielectric material ante enti? What is dielectric material? See, generally these acts like an insulators. So in general example, if you take mica, okay, sometimes paper is also taken as dielectric, dry air, okay, plastic, etc. So these are the general dielectrics are used between two parallel plate capacitors. Okay, ఎక్కువగా mica గాని paper గాని, okay, and of course sometimes glass plate is also taken as dielectric material. And the material dielectric constant varies with the material, K value. Plastic all under the dry air, paper, mica, glass plate. So these are some examples for dielectrics. Okay. Now what happens if these dielectrics are placed between two parallel plate capacitors? For example, here parallel plate capacitor there. I already told you in previous classes how the distribution of charge goes. Okay. ఇక్కడ ప్లస్ క్యూ ఉంటే అవుట్ సైడ్ ఎంత ఉంటుంది, ఇక్కడ మైనస్ క్యూ. హౌ టు గెట్ ద వాల్యూ? క్యూ ప్లస్ మైనస్ క్యూ బై 2, దట్ ఈస్ హౌ మచ్? క్యూ మైనస్ క్యూ బై 2, 0. సో అవుట్ సైడ్ వాల్యూస్ ఆర్ 0. ఇన్సైడ్ ఎంత అవుతుంది? క్యూ మైనస్ 0, క్యూ ప్లస్ క్యూ. అలాగే ఇది ఆపోజిట్ అవుతుంది. ఇది ఎంత అవుతుంది? ఇది కూడా అవుట్ సైడ్ 0. ఓకే, అండ్ వాట్ ఈస్ దిస్ వాల్యూ? మైనస్ క్యూ minus 0, that is minus q. So here inside both will be opposite side. Already I told in the previous classes. This is how the distribution goes. Now in between, if you put some dielectric material like glass plate or whatever thing, okay, when you put these dielectric materials, polarization occurs in this one. Polarization occurs. So what is the polarization here? See, all the positive charges will go in one side, please, and negative charges one side. Plus, 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 minus, because you know field always from positive to negative. Electric field is going away from positive towards the negative charge. So here polarization occurs. Plus minus, plus minus, plus minus, plus minus, plus minus, plus minus. Like this it will rearrange. Plus lani oka vaipu, minus lani oka vaipu. This is called as polarization in dielectric materials. Okay? So they will exchange the charges. Plus to the minus to that mali plus. Minus plus, minus plus and minus. And what happens if it in this fashion it goes? ఇలా వెళ్ళినప్పుడు ఏమవుతుంది? ఆల్రెడీ లోపల ఒక ఎలక్ట్రిక్ ఫీల్డ్ ఉంటుంది, E0, and due to this dielectric material, what happens? This also will develop some ఇండక్షన్. ఓకేనా, ఇది కూడా కొంత ఫీల్డ్ డెవలప్ చేస్తుంది కదా, ఇట్ ఆల్సో ఇండ్యూసెస్. సో ద రిజల్టెంట్ ఎంత అవుతుంది అప్పుడు, ఈ మైనస్ ఈఐ. దిస్ ఈజ్ ఒరిజినల్ వాల్యూ ఫ్రమ్ ద parallel plate capacitors. When dielectric material is introduced between the plates, in induction అంటే induced EMF, induced electric field is developed. ఫర్ ఎగ్జాంపుల్ ఇది సపోజ్ 10 అనుకోండి, 10 వాల్యూ. సపోజ్ ఇండ్యూస్ ఎలక్ట్రిక్ ఫీల్డ్ ఒక 4 అనుకోండి. సో వాట్ ఈస్ ఎఫెక్టివ్ వాల్యూ రిజల్టెంట్, 10 minus 4, 6. సో వాట్ హ్యాపెండ్, ద ఎలక్ట్రిక్ ఫీల్డ్ హెస్ డ్రాప్డ్, రెడ్యూస్డ్. ఓకే, సో ఈ మైనస్ ఈ ఈజ్ రెడ్యూస్డ్ డ్యూ టు ద ఇంట్రడక్షన్ ఆఫ్ ద డైఎలక్ట్రిక్ మెటీరియల్. అర్థమవుతుంది మీకు పాయింట్స్? సో రిజల్టెంట్ ఫీల్డ్ ఏమవుతుంది, ఆపోజిట్లో డెవలప్ అవుతుంది. ఈ డైరెక్షన్ ఇది, ఇది ఆపోజిట్ డైరెక్షన్ లోపల. ప్లస్ నుంచి మైనస్ కదా, ఇది ఇండ్యూస్డ్ ఈఐ, ఇదేమో ఈ జీరో. సో వాట్ విల్ రిజల్టెంట్, ఈ జీరో మైనస్ ఈఐ ఈజ్ రెడ్యూస్డ్. ఓకే, క్లియర్? ప్లీజ్ నోట్ డౌన్. Now in what way it will be reduced, that also I have to discuss. How much value is reduced from the original value. Have you copied this one? Right. So ఎంత వాల్యూ తగ్గుతుంది మనకి డైఎలక్ట్రిక్ మెటీరియల్ పెట్టడం వల్ల? See, ఆల్రెడీ ఒరిజినల్ వాల్యూ ఫర్ ఎగ్జాంపుల్ 10 అనుకుంటే, ఇండ్యూస్డ్ వాల్యూ ఫర్ ఎగ్జాంపుల్ 4 అయితే రిజల్టెంట్ 6 అయింది, అంటే తగ్గిపోయింది కదా. హౌ మచ్ ఇట్ ఈస్ రెడ్యూస్, E0 by k times. Okay, how much value it is becoming, 1 by k times of the original value, reduced value of electric field. Okay, so when dielectric material is introduced, what happens, the value decreases, effective E net value. E net value ఎంత అవుతుంది, because of the induced in opposite direction of the dielectric material, this and the original one is in this direction. So E0 minus EI is reduced. So how many times, 1 by k times అయిపోతుంది E net value. Clear? Due to the polarization. Clear? And we have a formula also. You can copy this one. E net electric field is equal to E original before minus EI. EI is the induced electric field due to the dielectric material. Okay na? So this is nothing but what? Again, E0 by K. E0 by K. Original value ki K times. 1 by K times it becomes the value, E net value. And this one you can take the formula in this fashion. EI sigma, you know already, infinity sheet you have charge density, charge per unit area. Sigma is equal to sigma into 1 minus 1 by k. These formulas are important for doing numerical problems. Sigma induced is equal to sigma into 1 minus 1 by k. And you know what is sigma for infinity sheets? E is equal to sigma by 2 epsilon naught. మీరు చూసే ఉంటారు parallel plates లో. So this is plus negative charge, field is going in this direction E1. ఓకే, పాజిటివ్ నుంచి నెగిటివ్. అలాగే ఇంకోటి కూడా టువర్డ్స్ నెగిటివ్ ఫీల్డ్ కూడా ఉంటుంది. సో వాట్ ఇస్ ద రిజల్టెంట్, E1 plus E2, 2 times. సో sigma by epsilon naught. This is the electric field between the plates. Charge density by epsilon naught. Okay na? So you can use this formula, sigma is equal to sigma into 1 minus 1 by k, where k is dielectric constant in the numerical problems, while solving numerical problems. Okay na? Sigma is the induced charge density and sigma is the original value. Sometimes this can be used as sigma naught also. Okay na? Clear? Right. Now let us go still further. After learning about the dielectric materials, let us see what happens to the potential difference between the parallel plate capacitors. Okay na? What happens, the value for the potential when between the parallel plates. Okay, that is before introduction of the dielectric material, after introduction of the dielectric material. అంటే డైరెక్ట్రిక్ మెటీరియల్ పెట్టక ముందు వాల్యూ ఏంటి, పెట్టిన తర్వాత వాల్యూ ఏంటి చూద్దాం. సో దీస్ ఆర్ parallel plate capacitors. For example, before dielectric material, this is after dielectric material. After dielectric material, this is okay. So in this, you know, field will be in this direction, EI, and this is E0. So net value is equal to E0 minus EI. Okay na? Now here, before putting the plate, what happens we'll see. We already know what is V. Delta V is equal to E into D, and already you have seen this is the field direction, this is the distance D. Distance D and E are in same direction. Theta is equal to 0. So cos 0 is equal to 1. Therefore, you have taken the magnitude. So magnitude delta V is equal to E into D. In before class I told you. Okay. So before introduction, what is the delta V? E0 into D. Before introduction of the dielectric material, formula ఏమవుతుంది E0 without any dielectric material. E0 into D. Equation 1. Now dielectric material is introduced like plastic or any other material. I told you example, plastic, dry air, mica or anything. So when introduced, what happens to the effective value? It decreases by k times E net. For the original value decreased by 1 by k times. Now what is new delta V? Potential. What is the formula? E into D. So what happens to the E value? Decreases by k times. So delta V is equal to, what is E0 into D? Delta V. That is delta V0. In other words, delta V0. So this value, if you observe, E0 into D is nothing but delta V0 by K. Okay. So finally, I can write this entire equation as V is equal to V0 by K. Potential becomes 1 by K times the original value. Potential becomes 1 by K times from these formulas. Clear? When dielectric material is introduced. Okay? In the same way now, let us see what happens to the capacitance, please. Please copy it. Right. Now, before and after, now let us see for the capacitance. Capacitance value ఏమవుతుందో చూద్దాం before and after. See, we already know for capacitance, before, this is before, you know Q is equal to CV. Original formula enti Q is equal to CV. So Q is equal to C naught into V. Okay, Q is equal to C naught into V. C naught into V naught will take. C naught into V naught. Before value. Now when you introduce the dielectric material, what happens to the capacitance? Capacitance becomes K times the original value. Capacitance ఏమవుతుంది? K times. Now we'll check it whether it is correct or not. We'll check it. So what is C here? It has to become like this, K times. So what is Q again formula? We have C is equal to Q by V formula. Okay? After the introduction of the material, dielectric material, Q is equal to CV or C is equal to Q by V. So here C is equal to, what is Q? What is Q here? So this is not Q0. Q is equal to C0 V0 kada. Q ante C0 V0 by V. Is it right? Oh, small mistake we done. See here, C is equal to Q by V, okay, that is equal to I can write as Q by what is V actually in the previous, just now I told you, what happens to V? V0 by K. Since potential becomes, what happens? 1 by K times after introduction of the material. So, new C value Q by V and Q by V0 by K. Put it here. C is equal to Q into K by V0, Q into K by V0. Okay, na? So, here from equation 1, what is Q by V0 please? C0. Q by V0, what is C0? So, C is equal to C0 into K, or C is equal to K into C0 or C0. So, this is the value. So, when you introduce the dielectric material, new capacitance becomes K times the original value, where C0 is the original value before putting the dielectric material. Clear? Okay? Any doubt? Right. Let us go to the next one. So, finally what we have learned is potential becomes 1 by K times, E becomes 1 by K times, C becomes K times, Q also becomes K times after putting the dielectric material. Now, one more additional information I am giving for you. For example, in the examination, if they gives metal conductor, for metal conductor in the examination, metal conductor, okay, if metal conductor is used, okay, in the parallel plate, metal conductor is used in the place of dielectric material, అంటే డైఎలక్ట్రిక్ మెటీరియల్ బదులు ఒక మెటల్ కండక్టర్ యూజ్ చేస్తే, ఓకే, దెన్ వాట్ హ్యాపెన్స్? As usual, you can observe here the figure. Charge positive to negative. So, in the between I am using a metal conductor. So, metal conductor here I am using. Of course, it is having opposite charges అలాగే ఉంటాయి, మీకు తెలుసు కదా, ప్లస్ ఇక్కడ, మైనస్ ఇక్కడ, minus sigma plus sigma charge density, okay, అలాగే plus sigma minus sigma charge density. Now ఈ సందర్భంలో ఏమవుతుంది ఒకసారి చూద్దాం. Here in this case K is taken as infinitive please for metal. K is taken as infinitive, and already we have learnt before what is E net. What is E net? E net already I told you as E0 by K. So therefore, for metal conductor between the plates, instead of dielectric material if you use it, then what happens to the E net? E0 by K is infinity for this one. Since K is infinity, what is 1 by infinity is 0. So therefore, E net is equal to G0 into 0, that is 0. అదవుతుందా? K infinity కదా, ఇక్కడ ఇన్ఫినిటీ పెట్టండి, 1 by infinity 0 కదా, E net is equal to 0. So you are getting E net 0 here because K is infinity కదా, ఇక్కడ పెట్టేసండి 1 by infinity. So E net is equal to 0. There is no net value, 0 you will be getting when you use metal conductor. ఆ కేసులో అయితే మీకు ఫార్ములా మారుతుంది. సిగ్మా ఇండ్యూస్ is equal to sigma into 1 minus 1 by K. Sigma induced is equal to sigma or sigma 0 into 1 minus 1 by K. Since K is infinitive, 1 by infinity becomes 0. So sigma induced is equal to sigma before. So no change in the charge density. For a metal conductor, instead of using dielectric material between the parallel plates. Sigma is equal to sigma. So it remains same value, no change values. Value change out. Okay, na? Now let us go to the next one. Almost we are coming to end of this chapter. Okay. That is next one ఏంటంటే ఒకవేళ మీరు ఒక డైఎలక్ట్రిక్ స్లాబ్ యూజ్ చేస్తే parallel plates లో suppose the distance between them is d, parallel plate capacitor. Okay. And here suppose if I am using a slab, dielectric slab of thickness T thickness, then what happens to the capacitance? See, derivation I am not doing directly, I am giving because mainly we are concentrating on MSET. If you want derivation, you can see this is what? Series connection. So series connection formula into 1 by C1 plus 1 by C2 plus 1 by C3. So here you will get it as epsilon naught A by D minus T plus T by K. Please note down this formula. Epsilon naught, you know the value, perimeter of free space, 8.85 10 power minus 12 coulomb square per Newton meter. Area of the plates, D, distance between the plates, T, thickness of the glass slab between the parallel plates. So D minus T plus T by K. K is the dielectric constant of the material. It will be given. You can use this formula because all are, you can see, connected like this. Series connections. So series connection formula else kada, parallel formula వేయాలి. 1 by C is equal to 1 by C1 plus 1 by C2 plus so on. If you put the formula, you will get the value here. This is one capacitor, this is one, this is one. Okay, na? This is one, this is one, and this is one. And for this one already you know, when introduce any glass slab, what are the new capacitance for this one? Capacitance ఏమవుతుంది? K times. The capacitance of this value becomes K times the value. That is C is equal to epsilon naught into A by D. Epsilon naught A by D. Okay? Any times పెరుగుతుంది ఇది? C is equal to K times. అంటే ఒరిజినల్ ఫార్ములా C is equal to epsilon naught A by D. ఇది K times అవుతుంది. అంటే K into epsilon naught A by D అవుతుంది. So like that you can take the value and put it and finally you will get the derivation. C is equal to epsilon naught A by D. It becomes K times 1 by C కాబట్టి D by K epsilon naught A. అలాగే remaining all you can take the values and you can substitute. Finally this is the derivation we are getting. When dielectric slab of thickness T is introduced, epsilon naught A by D minus T plus T by K. You can use the series formula 1 by C1 plus 1 by C2 plus 1 by C3. You will get the value. Because when you put the dielectric material, it becomes K times epsilon naught A by D. Remaining epsilon naught A by D, epsilon naught A. When you put the make a value, వచ్చేస్తుందండి. You can easily solve. So this is the glass slab formula. Now let us go to the last one, please. That is when battery is disconnected and when battery is continued. Okay, for example, suppose these are the parallel plates. These are the parallel plates. These are the parallel plates, capacitors. Suppose for this one battery is there, for example. First battery is connected. Okay. Battery is there. So current is flowing. So when battery is there, what happens? First case 1. Battery is there. Battery present. First. Present అయినప్పుడు వాల్యూస్ ఏమవుతుంది? ఛార్జ్ సేమ్ ఉంటుంది. Q is equal to Q0. So ముందు ఇనిషియల్ వాల్యూస్ వేద్దాం, తర్వాత మిగతా వాల్యూస్. ఫస్ట్ ఇనిషియల్ వాల్యూస్ రైట్. When battery is there, Q0, E0, V0, C0, U0. These are the initial values. Okay, na? C0, capacitance initial, potential initial, electric field initial, charge initial, and U, energy. U0 is the energy. So how you will get U0? Q square by 2C formula you can use. Q square by 2C. Therefore, U0 is equal to Q square by 2C. Q square by 2C means what is Q here? By 2C. What is C here? C0. This is the energy stored formula. When battery is there, initial values Q0, E0, V0, C0. So energy avutundi Q square. I told you three formulas. Half CV square, Q square by 2C, QV by 2. So Q0 square by 2C is equation 1. Okay, na? Equation 1. Now what we'll do, we'll remove the battery. Battery remove chestar. Can you draw the figure this side? I'll draw here. Plus, minus. Here no battery is there, battery is removed. Okay, and a dielectric is introduced. Dielectric. So dielectric is introduced. So when battery is removed, battery removed, then charge the charge remains same. Whatever charge is there, same charge. Now what happens to the values, we will try to find out. When battery is removed from the connection, what happens to the values, please? One by one radam andi ikkada. Charge remains same. There is no effect of charge. Q is equal to Q0. What happens? The remaining things, V becomes what? V becomes 1 by K times. E becomes 1 by K times. Capacitance becomes K times. Charge becomes K times. And U is also reduced K times. Okay, that also will calculate. So E becomes 1 by K times. V 1 by K times V0. Okay, Q remains same. Q is equal to Q0. Q remains same and sorry, here I am written K times. Because battery is removed and in the place of battery you are introducing a dielectric material. Okay, na? With constant K. So what happens? Capacitance K times, energy, electric field K times decrease, potential also decrease by K times. Now let us calculate what happens to the new energy. When battery is removed, we will see what happens to new energy. So energy is equal to formula and original ga half CV square, లేదా same formula we will use. That is Q square by 2C. So energy is equal to half into Q square by 2C. Q remains same by C in the K times. So observe carefully, Q square by 2C naught. Q square by 2C naught is equal to U naught. Therefore, U is equal to U naught by K. So what is the new energy? Decreases by 1 by K times. Decreases by 1 by K times. Please note down. This is what when battery is kept once in the connection and next battery removed. ఒకటే గుర్తుపెట్టుకోండి, బ్యాటరీ ఉన్నప్పుడు ఛార్జ్ ఉంటుంది, రిమూవ్ చేసిన తర్వాత కూడా ఛార్జ్ అలాగే ఉంటుంది. ఓకే, ఛార్జ్ ఏం మారదు. ఓన్లీ ఏం మారుతున్నాయి? డైఎలక్ట్రిక్ మెటీరియల్ పెట్టిన తర్వాత V is changing, E is changing, Q remains same and C is also changing. Next one. Next one. Okay. Next one and last one, I think this one will complete. So now what we'll do the last case in this one. Suppose when battery is not removed, okay, case 2. Case 2, battery is continuing. Battery is continuing. Continuing, okay. Battery is there and dielectric is introduced slowly. బ్యాటరీ తీయలేదండి, కెపాసిటర్ మధ్యన బ్యాటరీ ఉంది, బ్యాటరీ is there, okay, battery is there, and slowly dielectric is introduced. Slowly dielectric is introduced. Slowly dielectric material is used. సో ఈ కేసులో ఏం జరుగుతుంది ఇప్పుడు చూద్దాం. బ్యాటరీ రిమూవ్ చేయాలి, బ్యాటరీ ఉంది, slowly dielectric is introduced. Now in this case what happened, బ్యాటరీ అక్కడే ఉంది కాబట్టి we remain same. And what about the remaining items? ఫస్ట్ ఐటమ్స్ ఏముంటాయి, బ్యాటరీ ఉంటుండగా, ఓకే, బిఫోర్ ఏంటి, డైరెక్ట్కి పెట్టక ముందు బ్యాటరీ ఉంది కాబట్టి వాట్ ఆర్ ద వాల్యూస్, Q0 ఇనిషియల్ ఛార్జ్, ఓకే, అలాగే ఇనిషియల్ పొటెన్షియల్ V0, అలాగే ఇనిషియల్ C0 capacitance, and E0 field, initial field, and U0 energy. These are the initial values when the dielectric is slowly not introduced. Introduce చేయక ముందు Q0 initial charge, initial potential, initial capacitance, initial field, initial energy. Now after dielectric పెట్టిన తర్వాత ఏమవుతుంది, ఛార్జ్ మారుతుంది, V becomes V0 only, but what changes will be there, డైరెక్ట్గా పెట్టిన తర్వాత కెపాసిటెన్స్ మారుతుంది, ఆఫ్ కోర్స్ K times, ఛార్జ్ కూడా మారుతుంది K times, ఓకేనా, కెపాసిటెన్స్ is changing K times, ఛార్జ్ is changing, ఓకే, పొటెన్షియల్ చేంజ్ అవుతుంది కాబట్టి ఇది కూడా చేంజ్ అవ్వదు, ఫీల్డ్ E is equal to E0. Now what is the energy? Energy is equal to half C V square. So energy is equal to half C. What is C? K times C0. And what is V? V0 only, no changement. Okay, V0 square. So half C V square. This is nothing but what? U0. Okay, na? U0. So energy becomes, what happens, K times the initial energy. Okay, energy stored becomes K times, increases by K times of the original value. Okay, అంటే ఓన్లీ బ్యాటరీ ఉన్నప్పుడు ఎనర్జీ ఏముందో, బ్యాటరీ ఉంటుండగా స్లోగా when you put the dielectric material, energy becomes K times the original value. This is very important అండి regarding the examination point of view. Okay, and we are last one, we are having only one formula. With that I'll end up this chapter. Only one is left over, common potential. Okay, common potential formula please, last one. Clear? Very important topic under the electrostatics. In the examination they are asking common potential formula, common potential okay, common potential for, okay, suppose for example this is one charge, this is one charge, let the values are Q1 Q2, okay, both are identical. First of all, both are identical means same, okay, so both are coming in contact. What happens, Q1 plus Q2 by 2 charge, in the same way Q1 plus Q2 by 2, so charge will becoming half, both are identical ikkada, Q1 plus Q2 by 2 and Q1 plus Q2 by 2, when both are coming in contact, common potential, okay, and ikkada conductors are identical and same, conductors are identical. Now second case, suppose the conductors are not identical, సేమ్ కాదంటే ఇది R1 ఇది R2 రేడియస్, C1 C2, capacitance, V1, V2. Now they are coming in contact. Now what will be the common potential? Conservation of charge. Apply conservation of charge. So conservation of charge apply cheste, conservation of charge. When you apply, what happens? See, Q1 plus Q2, Q1 dash plus Q2 dash. When you apply conservation of charge, Q1 plus Q2 is equal to Q1 dash plus Q2 dash. Okay. Now when you apply, in this case what happens? What is Q1? Q is equal to CV kada. C1 V1 plus C2 V2 is equal to common potential. C1V plus C2V. Leda, I'll write it here. C1 V1 plus C2 V2 by C1 plus C2 is equal to V. Okay, na? So C1 V1 plus C2 V2 by C1 plus C2 is equal to V. That is the common potential. Okay? So this is how you will be getting for conductors which are not identical, same kaadu, with different values, R1, R2, C1, C2, V1, V2. ఏమైంది? C1, C2, C1 V1 plus C2 V2 by C1 plus C2. In the same way, if you want ratio of the charges, ratio ఎంత అవుతుంది value? If you want the ratio of the charges, in this case, you can get like this. Q1 by Q2 is equal to, okay, Q1 and then now C1 V1, C2 V2. అంతేనా? C1 V1, C2 V2. A common potential అయింది కదా, C1V, C2V. C1V, C2V. VV gets cancelled. What happens? C1 by C2. So the value of Q1 అంటే ఇక్కడ న్యూ వాల్యూ, సారీ Q1 డాష్ అండి, Q1 డాష్ ఎంత అయింది? C1V. Q2 డాష్ ఎంత అయింది? C2V. సో Q1 డాష్ బై Q2 డాష్ ఎంత అవుతుంది? C1 by C2. In the same way, you can calculate for spherical conductor. For spherical conductor, already I have derived in the before chapters 4 pi epsilon naught R. So what happens now? C1 by C2 value ikkada emutundi? C1 by C2 4 pi epsilon naught R1 by 4 pi epsilon naught R2. So what is the value? R1 by R2. So those are the values for C1 by C2 ante C1 dash by C2 dash for spherical conductors. Clear? C1 dash by C2 dash is equal to R1 by R2. Please try to remember all this value. These are very, very important in solving the problems. And please make a note, this is the end of the electrostatics chapter. Completely we have done part 1, part 2, part 3, part 4, and this is part 5. Again we'll be meeting in the next chapter, that is current electricity. Okay? Right.